The expansion of the universe is a phenomenon that has fascinated scientists and curious minds alike. Why, as we observe the cosmos, do we discover that galaxies are moving away from each other? This seemingly simple question is just the tip of the iceberg of a much deeper mystery. At the heart of current cosmology, the expansion of the universe not only redefines our understanding of space and time, but also raises questions that lead us to explore the unknown. Every time we look up at the night sky, we are confronted with a vast sea of stars and galaxies. But how is it possible that all of this is in constant motion? For a long time, it was thought that gravity would act as a natural brake on the expansion. But recent discoveries have challenged this idea. The expansion not only continues but is accelerating. What forces drive this phenomenon? The answer to this question is not only crucial for understanding the universe, but also opens the door to concepts that seem straight out of science fiction. The importance of these mysteries lies in the fact that by unraveling them, we are not only seeking answers about the cosmos, but also exploring our own existence. Are we really alone in this vast expanding universe? Are there other universes forming in parallel to ours? These questions lead us to reflect on the nature of reality itself. As we delve deeper into the subject, we encounter the surprising idea that the expansion of the universe might be related to the way we experience time. Is it possible that time and space are interconnected in a way we do not yet understand? The theories attempting to explain the expansion of the universe also suggest that dark energy, a mysterious force that seemingly makes up most of the cosmos, plays a crucial role in this process. With each new discovery, more questions arise. How can we reconcile the different measurements of the rate of expansion? And if the universe is expanding, what does that mean for the ultimate fate of the cosmos? Are we heading towards a big freeze, where everything cools and moves away, or towards a big rip, where the expansion could tear apart even the fabric of space and time? In this exciting journey through the mysteries of the expansion of the universe, we find ourselves in a constantly changing landscape. Science offers us a glimpse of what could be, but it also reminds us of how little we really know. As we continue to explore these questions, we face the immensity of the cosmos, a place full of wonders and enigmas that invite us to keep asking. So, are you ready to embark on this adventure and discover the secrets that await beyond the stars? The expansion of the universe is a phenomenon that has intrigued scientists and enthusiasts alike, but one of the most puzzling aspects is the acceleration of this expansion. Why, despite gravity, is the universe expanding faster and faster? To understand it, we need to delve into the nature of dark energy, a mysterious force that seems to be responsible for this acceleration. What exactly is dark energy? Although it constitutes about 70% of everything in the universe, it remains one of the greatest enigmas of modern cosmology. It has been proposed that this energy acts like a kind of anti-gravity, pushing galaxies away from each other. But how can something we cannot see have such a powerful effect on the structure of the cosmos? Imagine you are inside an inflating balloon. As the balloon expands, points on its surface move away from each other. If that balloon could keep inflating indefinitely, what would happen to the points on the surface? Dark energy is a bit like the air that inflates that balloon, but here's the question: what force is really inflating our universe? Scientists have measured the rate of expansion using different methods, but the results are surprising. We obtain readings that show the expansion is accelerating, which contradicts the intuition that gravity should slow this process down. What is happening here? Are we observing a phenomenon that challenges the laws of physics as we know them? One of the most intriguing theories is that dark energy could change over time. Some proposals suggest that in the past, this force may have been weak, allowing gravity to dominate the expansion. However, in the present, its influence has increased, leading to an acceleration that we cannot ignore. This leads us to wonder, if dark energy can change, what does that mean for the future of the universe? Some research has begun to explore the possibility that dark energy is not uniform throughout the cosmos. Perhaps there are regions where its effect is stronger or weaker, If this is true, could we observe differences in expansion in different parts of the universe? This could lead us to a new understanding of how the cosmos is structured and behaves on a large scale. But dark energy is not the only thing raising questions. Dark matter, which makes up a considerable part of the universe, also plays a crucial role in this mystery. How does dark matter interact with dark energy? Could it be that both forces are in a delicate balance, mutually influencing the expansion of the universe? This is a fascinating territory that we have yet to fully explore. As telescopes become more advanced and observation methods improve, scientists hope to obtain more precise data on the acceleration of expansion. But in the meantime, we face questions that have no clear answers. Could it be that at the heart of all this lies a new physics that we have yet to discover? The possibility that there are laws of the universe that remain unknown to us is both terrifying and exciting. Some researchers have begun to consider the idea that the acceleration of the universe's expansion might be related to the nature of space-time itself. Is it possible that space itself is experiencing a type of expansion that we do not fully understand? This notion challenges our perception of reality and invites us to reconsider what we think we know about the universe. The question persists: what is really driving this acceleration? Some theoretical models suggest that we might be at the beginning of a new cosmological era where dark energy could be a temporary phenomenon. But what would that mean for the ultimate fate of our universe? Could we be living in a transitional phase towards a future we cannot yet imagine? As we reflect on these issues, it is important to remember that science is in constant evolution. What seems like a mystery today could be resolved tomorrow with a simple discovery. The acceleration of the universe's expansion is just one of many questions that remain for us to answer. The search for answers takes us to every corner of the cosmos, from the far reaches of galaxies to the depths of dark matter and dark energy. And in this quest, each new discovery brings us one step closer to understanding our place in the vast universe. So, are you ready to continue exploring these mysteries? If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. Dark matter is one of those phenomena that sparks the curiosity of any cosmos lover. But what exactly is it? Although we cannot see or touch it, we know it is there, exerting a powerful influence on the universe. It is estimated to constitute about 25% of the total mass and energy of the cosmos. But why is it so important for understanding the expansion of the universe? Imagine you are a space explorer, navigating through a vast stellar ocean. You realize that galaxies are not distributed evenly. Some regions seem to have more stars, while others look deserted. This mystery is largely due to dark matter, which acts like an invisible skeleton, shaping the structure of the universe. But does it really help shape the expansion of the universe, or does it simply go along with it? Gravity, that force we know so well, plays a crucial role here. On one hand, dark matter attracts galaxies, causing them to cluster and form groups. But on the other hand, the accelerated expansion of the universe seems to be surpassing even the pull of gravity. So an intriguing question arises. Is dark matter in a kind of tug-of-war with expansion? Could it be that instead of helping to slow down the pace of expansion, it is actually collaborating with dark energy to accelerate it? Another concern that arises is whether dark matter has a fundamentally different nature from the matter we know. While visible matter, like stars and planets, interacts with light and can be observed directly, dark matter neither emits nor reflects light. This complicates its study even further. Could it be that we are underestimating its influence on the behavior of the universe? Scientists have proposed various theories about the nature of dark matter. Some suggest it could be composed of exotic particles that we have yet to detect, while others propose it might be a manifestation of gravity on large scales. This latter idea leads to another fascinating question. Could dark matter be an indication that our understanding of gravity is incomplete? The dilemma becomes even more complicated when considering that dark matter might be influencing the expansion of the universe in ways we do not yet understand. While some theories suggest it could be acting as a brake on expansion, others propose that it could be driving it. Could we be observing a cosmic chaos where opposing forces play their own game on a grand scale? Moreover, multiple experiments and observations have been conducted to try to unravel this mystery. From studies of supernovae to the observation of cosmic background radiation, scientists are trying to piece together the puzzle. But so far, the nature of dark matter remains an enigma. Are we looking in the wrong place, or have we simply not developed the right technology to detect it? Computer simulations have been fundamental in our search for answers. These simulations allow scientists to model how the universe would behave under different dark matter conditions. But what do these models really tell us about expansion? The results often lead to more questions than answers. And uncertainty remains the norm. It is fascinating to think about how dark matter could be the key to understanding the expansion of the universe. If we manage to unravel its secrets, we could gain a clearer insight into how the cosmos truly works. But what if we never fully understand it? Are we destined to live in a universe full of unknowns? As researchers continue their quest, dark matter could be one of the most important pieces of the cosmic puzzle. But could there be more surprises along the way? Perhaps dark matter is not a single substance, but a collection of phenomena that manifest in different ways. And if so, how much more is there to discover? In this journey through the mysteries of the universe's expansion, dark matter stands out as a key element. Its influence is undeniable, but its true nature remains a mystery. In the end, the search for answers leads us to question what we think we know about the cosmos and our place in it. Human curiosity has been the driving force behind many scientific advancements. Dark matter, with its elusive nature, reminds us that there is still much to learn. We may not have the answers today, but each discovery brings us closer to a better understanding of the vastness of the universe. Ultimately, it is possible that dark matter is not just a physical phenomenon, but a symbol of the constant quest for knowledge. It invites us to explore the unknown, to challenge our assumptions, and to move forward despite uncertainties. Because after all, every mystery solved opens the door to new questions, and that is what makes science so exciting. The geometry of the cosmos is a fascinating topic that leads us to question the very nature of the universe. But what does it really mean for the universe to be flat, curved, or infinite? And most intriguingly, how can the expansion of the universe be the key to answering these questions? The shape of the cosmos is not just a curious fact, it influences how we understand gravity, matter, and energy. When we talk about the geometry of the universe, we often encounter three possibilities: flat, curved, and open. A flat universe, like a stretched sheet of paper, suggests that gravity and dark energy are in perfect balance. But what happens if the universe is curved? In that case, gravity could be strong enough to cause the cosmos to curve back on itself, creating a sort of loop. Now, what implications would this have for expansion? The expansion of the universe has been accelerating, raising a troubling question. If the universe is curved, could we eventually return to a point of collapse? Or, if it is flat, will it continue to expand indefinitely? The geometry of the universe could indeed be the determining factor that indicates where everything we know is headed. But how is this geometry determined? Astronomers use observations of cosmic background radiation, which is like the echo of the Big Bang, to try to decipher the shape of the universe. This radiation contains small anisotropies, or temperature variations, that can give us clues about the structure of the cosmos. However, this data is complex and often difficult to interpret. Are we seeing a universe that is truly flat, or is there more to the story than meets the eye? Einstein's theory of relativity also plays a crucial role here. According to this theory, the presence of mass and energy can curve space-time. But how does this translate into the expansion of the universe? If dark matter and dark energy are present, could they be shaping the form of the cosmos as it expands? The answers to these questions are not only a challenge for scientists, but also open the door to countless possibilities. The idea of an infinite universe is equally perplexing. If the cosmos is truly infinite, what does that mean for expansion? Could there be regions of the universe that we will never be able to observe due to the speed of expansion? Imagine a universe where matter and energy are distributed in an endless space where expansion is a constant and every corner moves away from the other. How would this affect our understanding of life and existence? We must also consider the concept of homogeneity. Despite the vast distances between galaxies, the universe exhibits a surprising uniformity on a large scale. But how can this be possible in an expanding cosmos? This is a puzzle that has baffled cosmologists for decades. Expansion seems to create a homogeneous universe, but geometry suggests that there are still significant variations that we need to understand. As we explore these questions, we encounter the notion of parallel universes. If the expansion of the universe is a phenomenon that occurs within a broader framework of bubble universes, could the geometry of the cosmos be even more complex than we imagine? In this perspective, each universe could have its own shape, its own geometry, and its own history of expansion. What implications would this have for our place in the cosmos? As we delve into the mystery of the geometry of the universe, we cannot overlook the influence of dark energy. This mysterious force seems to be driving the acceleration of expansion, but its nature remains a puzzle. If dark energy acts uniformly throughout the cosmos, could it also be affecting the very geometry of the universe? The connection between expansion and geometry is a thin thread that we are still trying to weave. The final question we must ask ourselves is, how does our perception of the geometry of the universe affect our understanding of time? If expansion is intrinsically related to how we measure and experience time, then we might be facing a new paradigm. The way we understand time could be fundamentally linked to the geometry of the cosmos. What does this mean for our existence and our quest for answers in the vast universe? In conclusion, the geometry of the cosmos is not just a technical aspect of cosmology. It is a mystery that invites us to reflect on our place in the universe. Expansion, curvature, and the shape of the universe are fundamental questions that lead us to explore not only the cosmos but also our own existence. Are we ready to face what we discover on our journey through the mysteries of the expansion of the universe? Could we be living in a universe that is just a bubble in a sea of realities? This idea has captured the imagination of scientists and philosophers alike, challenging our understanding of existence and the cosmos. The notion of bubble universes suggests that our expansion is not an isolated phenomenon but one of many, each with its own characteristics and physical laws. But how did we arrive at this intriguing conclusion? The first hints of the existence of these parallel universes come from the theory of inflation. According to this theory, just after the Big Bang, the universe underwent an incredibly rapid expansion. Much faster than what we observe today. This initial expansion could have created bubbles of space-time, each of which became its own universe. Isn't it amazing to think that what we consider our reality could be just a small part of a much vaster whole? The idea of bubble universes also raises fascinating questions about the properties of physics. If there are other universes, what laws of nature might govern them? Could there be universes where gravity is so weak that stars never form, or where time flows differently? The mere possibility that other realities exist leads us to question what we truly understand about our own universe. Now, if our expansion is just one among many, what implications would this have for our understanding of the Big Bang? Perhaps it was not a unique event, but rather a continuous process of universe creation. Could it be that every time a bubble universe forms, a new expansion is triggered? This idea opens the door to an infinite cycle of births and deaths of universes, each with its own evolutionary path. The notion of bubble universes is also related to the concept of the multiverse, which has been a source of controversy and debate in the scientific community. Some argue that, due to a lack of direct evidence, we should be skeptical of such claims. However, others believe that current mathematical models and cosmological observations suggest that the multiverse could be a reality. Should we then expand our minds beyond what we know and accept the possibility that there is much more in the cosmos than we can observe? With each new discovery in cosmology, more questions arise. If we live in a multiverse, how does this affect us here and now? Could we one day find a way to communicate with another universe or even travel to it? The possibilities are so vast that they are almost overwhelming, but they are also exciting. This leads us to wonder, what does it mean to be human in an ocean of realities? The theory of bubble universes also has its detractors. Some scientists argue that due to the lack of concrete evidence, these ideas remain in the realm of speculation. However, science is constantly advancing, and what seems like fantasy today may become reality tomorrow. Isn't it fascinating to think that our current limitations could be surpassed in the not-so-distant future? Bubble universes also confront us with the idea that our reality may not be unique. If each universe has its own characteristics, what does this mean for our perception of life and the universe? We could be just one of many civilizations struggling to understand our place in a vast sea of realities. Is it possible that other versions of ourselves exist in these alternate universes, living completely different lives? In exploring this notion, we must also consider the relationship between the expansion of the universe and the creation of these bubble universes. Is it possible that the force driving our expansion is also shaping other realities? This dilemma raises an even deeper question. What is the role of dark energy in all this? Dark energy, which is believed to drive the acceleration of expansion, could be the key to understanding how and why these universes form. As we delve deeper into these ideas, science fiction begins to intertwine with cosmology. Books and movies have explored the notion of multiple realities, but real science is starting to address similar questions. Could it be that one day fiction becomes reality? All of this leads us to reflect on our own existence and the role we play in this vast cosmos. The belief in bubble universes also raises questions about the fate of our civilization. If there are infinite realities, what significance does what we do in this one hold? However, the answer might be that every action we take has an impact on our particular bubble, giving value to our lives and decisions. Could it be that in the end, what truly matters is how we choose to live in our own universe? Ultimately, the idea of bubble universes not only challenges our understanding of the cosmos, but also invites reflection on our own existence. Every time we look up at the starry sky, we might be contemplating other worlds, other selves in a vast and mysterious multiverse. What discoveries await us in the future? Only time will tell, but the journey to understand our reality and its possible plurality has already begun. Cosmic background radiation is one of the oldest echoes of the universe, a kind of whisper that reaches us from the moment of the Big Bang. But what are those small variations we find in this radiation? And why are they so puzzling? In this vast sea of energy, there are details that seem to clash with our current theories about the expansion of the universe. Could it be that there is something fundamental we still do not understand? The small fluctuations in cosmic radiation are fascinating because they tell us a story. They are remnants of the universe's youth, moments when particles and energy were beginning to shape what we know today. However, when analyzing these variations, we face an intriguing dilemma. Why do they not match the models we have constructed? Scientists have developed sophisticated theories to explain expansion, but when it comes to these patterns in radiation, the puzzle becomes more complicated. Imagine you are trying to assemble a puzzle, and as you progress, you realize that pieces are missing. That is what we feel when studying cosmic radiation. On one hand, we have the theory of inflation, which suggests that the universe underwent an extremely rapid expansion just after the Big Bang. But as we delve into the details, we realize that this theory cannot fully explain those small variations we observe in the radiation. So, what do these variations really tell us? Some scientists believe they could be hints of more complex structures in the universe, perhaps influenced by dark matter or even dark energy. But here arises a new question. Could it be that we are looking at the problem from the wrong perspective? What if the expansion of the universe is not the only factor affecting these variations? The relationship between cosmic radiation and the expansion of the universe is a field of study filled with questions. For example, why do some regions of the universe appear to be denser than others? This could be related to how expansion has affected matter over time. If the expansion of the universe is uneven, then the variations in cosmic radiation could be a manifestation of that inequality. But how do we measure that, and what does it mean for our overall understanding of the cosmos? And this is where the enigma becomes even deeper. Modern cosmology is based on the idea that the universe is homogeneous and isotropic, meaning it looks the same in all directions and on a large scale. However, the small variations in cosmic radiation suggest that, on much smaller scales, there is a complexity we have not managed to capture. Could it be that the expansion of the universe is creating a kind of fabric where irregularities are the norm rather than the exception? As astrophysicists continue to investigate these questions, new theories also emerge. Some suggest that dark energy, that mysterious force responsible for the acceleration of expansion, could be interacting in ways we do not yet understand. Is it possible that dark energy is influencing cosmic background radiation in ways we have not anticipated? Perhaps the answers are beyond our current reach, waiting to be discovered by future generations of scientists. Amid this confusion, it is essential to remember that science advances through curiosity and exploration. Every new piece of information we gather about cosmic background radiation brings us one step closer to solving the mysteries of the universe's expansion. But for that, we must be willing to question what we think we know. How far are we willing to go to uncover the truth about our cosmos? In the end, cosmic background radiation is not just a fascinating phenomenon, but also a window into the past, a mirror reflecting the evolution of the universe. Each variation is a clue to the processes that shaped our cosmos, and each unanswered question is an invitation to keep exploring. The quest for answers is what drives science forward, and in this journey, every discovery opens the door to new questions. Therefore, despite the confusion that cosmic radiation may generate, it is a reminder that the universe is a place full of mysteries waiting to be unraveled. The expansion of the universe, with all its complexities, invites us to keep probing, to keep marveling, and to never stop asking what lies beyond what we can see. The history of the cosmos is still an open book, and each page we turn reveals more about the vast and enigmatic stage on which we live. The expansion of the universe is a fascinating phenomenon, but what has truly captured the attention of scientists is the growing discrepancy in the measurements of that expansion. Why do two different methods for calculating the rate of expansion yield such contradictory results? This question is known as the Hubble tension, and it is a puzzle that has baffled cosmologists for years. On one hand, we have the classic method that relies on observing the light from distant supernovae. These stellar explosions are incredibly bright and act as beacons, allowing us to calculate their distance. From this, we can determine how fast they are moving away from us, and therefore the rate of expansion of the universe. However, when scientists apply this method, they find a result indicating that the universe is expanding at a surprisingly high speed. On the other hand, there is another method that uses cosmic microwave background radiation, the echo of the Big Bang that we can still detect in the cosmos. This approach tells us that the expansion should be slower. So what is going on here? Why do these two very different methods lead us to such opposing conclusions? Some scientists have begun to question whether we truly understand the nature of dark matter and dark energy, the components that, in theory, should be influencing the expansion of the universe. If our assumptions about them are incorrect, this could be affecting the measurements we obtain. Is it possible that there is something else we have not considered? The Hubble tension is not only challenging our ideas about the expansion of the universe, but it is also opening doors to new theories. For example, some researchers suggest that there could be variations in the speed of light over time. Can you imagine a universe where light does not always behave in the same way? This could drastically alter our understanding of astronomical measurements. And if that were not enough, there is also the issue of relativity. The way we understand space and time may be limited by our observations. Could it be that deep down the universe does not expand in the way we believe and that our theories are outdated? The idea that our measuring tools might be inadequate is unsettling, but it can also be exciting. The dilemma of the Hubble tension also raises the possibility that we are living in a constantly changing universe. If the measurements are inconsistent, could we be facing a cosmos that evolves even in its own expansion? Is it possible that the universe is more alive than we think, changing its rules as we observe it? Reflecting on these questions, it is evident that we are at a crucial moment in the history of cosmology. The Hubble tension is not just a mathematical discrepancy, it is an invitation to rethink what we know. Each new discovery offers us the opportunity to re-examine our theories and open ourselves to new possibilities. Meanwhile, telescopes continue to gaze at the sky, searching for answers that may solve this puzzle. Will future observations clarify why there is such a notable difference in the rates of expansion? Or will they lead us to even more intriguing questions? This enigma also reminds us that, although we have made enormous strides in our understanding of the universe, there is still much we do not know. The Hubble tension is not just a problem to be solved, it is a reminder that there are mysteries in the cosmos that are still waiting to be uncovered. In the end, the search for the truth about the expansion of the universe is a quest for ourselves. Every answer we find leads us to new questions, and every question brings us a little closer to understanding our place in the vast cosmos. What discoveries await us in the future? Only time will tell. But what is clear is that the universe still has many secrets to reveal to us. The relationship between the expansion of the universe and time is one of the most fascinating questions facing today's scientists. What if I told you that the way we understand time could be tied to this cosmic expansion? What if the very flow of time is a reflection of how the universe expands around us? It is a mystery that invites us to delve into the unknown. To begin, let's consider a fundamental idea in our perception of time. We experience it as a sequence, a before and after, where events seem to occur in a linear order. However, in the vast universe, this notion of time may be more complex than it appears. Could it be that time is not just a measure of change, but is intrinsically linked to the expansion of space itself? Scientists have discovered that the universe is not only expanding, but doing so at an accelerating rate. This raises an intriguing question. Is it possible that time is also accelerating? Imagine that time behaves similarly to the expansion of the universe. Could it be that the laws governing time change as the cosmos expands? This concept challenges our most basic notions of how we experience reality. Some theorists suggest that time could be another dimension of space, a fabric that intertwines with it. Thus, the expansion of the universe not only separates galaxies but also shapes time itself. How are space and time related in this vast cosmic tapestry? The answer may lie in how gravity affects both. Take, for example, the phenomenon of time dilation. When an object moves at speeds close to the speed of light, time for that object passes more slowly compared to one that is at rest. In this way, the expansion of the universe could be influenced by how we experience time. Is it possible that time is distorted in different regions of the cosmos due to variability in expansion? It is fascinating to think that time may not be constant throughout the universe. In some areas where gravity is stronger, time could flow differently. What implications would this have for our understanding of the history of the universe? The answer to this question could be crucial in unraveling the mysteries of expansion. Moreover, the notion of an expanding time leads us to contemplate the future of the cosmos. If the universe continues to expand at this accelerated rate, how will that affect our perception of time in the future? Will we be doomed to observe an increasingly distant universe where time becomes an ever more solitary and isolating experience? This scenario invites us to reflect on our own existence amid the vastness of the cosmos. And if we think of time as a malleable dimension, could we ever manipulate it? Imagine a future where advances in our understanding of the universe's expansion allow us to explore time in ways that today seem impossible. Would it be possible to travel through it or even alter our destiny on the timeline? Scientists continue to investigate these questions, but the reality is that we are still far from fully understanding how time and the expansion of the universe are intertwined. Are we getting closer to the answer, or are we delving even deeper into the mystery? Each discovery leads us to new questions, and each answer seems to open more doors to the unknown. Exploring these concepts reminds us that the universe is an incredibly complex and astonishing place. As we advance in our understanding of cosmology, it is vital to keep an open mind and be willing to question what we think we know. Could there be hidden truths waiting to be discovered that will change our way of seeing the universe and time? Ultimately, the connection between the expansion of the universe and time challenges us to reconsider our place in the cosmos. It invites us to reflect on how our lives unfold in a constantly expanding cosmic stage. What does this mean for us, and how does it affect our perception of the present, the past, and the future? Exploring these mysteries may be the first step toward a new understanding of our existence. So the next time you look up at the starry sky, remember that you are not just observing the universe, you are also witnessing the dance of time and expansion, a cosmic spectacle that continues to reveal its secrets. Are we ready to embrace the complexity of this relationship? Are we prepared for the mysteries that still await us? The answers to these questions could define the next era of cosmic exploration. What is the final destiny of the cosmos? This question has intrigued astronomers and scientists for generations. As the universe expands, we find ourselves in a scenario full of possibilities but also uncertainties. Will this expansion continue forever, or will there come a time when it stops and everything collapses back in on itself? Imagine a balloon that is slowly inflating. At first, it seems that everything is calm. But as it inflates more, what happens? Could that balloon eventually burst? The analogy is valid for our universe. The current expansion is like that balloon in full growth, but what will happen when it reaches its limit? Since the beginning of time, the universe has been in motion. The expansion began with the Big Bang, a cataclysmic event that gave rise to everything we know. However, the rate of that expansion has changed over time. At one point, it was thought that gravity could slow down that growth, but in an unexpected turn, we discovered that the expansion was accelerating. What does this mean for the future? Are we destined for a universe in perpetual growth? One of the most discussed theories is that of the Big Freeze. This scenario suggests that the universe will continue to expand indefinitely, leading to a cold and empty future. Energy would disperse, stars would go out, and darkness would reign. Imagine a vast space where there is no light or heat, an eternal silence. Is this really the destiny that awaits us? On the other hand, there is the hypothesis of the Big Crunch, which posits that eventually gravity could overcome expansion and cause the entire universe to collapse in on itself. In this scenario, galaxies, stars, and even planets would come together again into a single point. Could this be the eternal cycle of creation and destruction? A universe that is born, expands, and ultimately contracts. However, there is more. Some theories suggest that we could be in a kind of oscillating universe, where after each collapse a new Big Bang would initiate another cycle of expansion. Is it possible that our existence is just one of many cycles, an endless echo of universes that are born and die, a cosmic dance that never ends? But what about dark energy in all of this? This mysterious force, which seems to be behind the acceleration of expansion, could influence the final destiny of the universe. Could its role be to keep the universe in a state of eternal expansion, or could it eventually change direction? The truth is, we still do not know. And as we reflect on these possible destinies, we cannot ignore the idea that time itself might be tied to the expansion of the universe. If the universe continues to expand, does this mean that time as we know it will also stretch? Or is there a point at which time itself could stop, becoming an irrelevant concept in a desolate universe? Questions abound, but answers are elusive. In this vast universe, as we look toward the stars, we face the reality that our destiny may be as uncertain as the cosmos itself. Each discovery in cosmology leads us to new questions, and each answer reveals another layer of mystery. Is the end of the universe a tragic event or a transition to something new? The final destiny of the cosmos is a puzzle that invites reflection. It shows us how fragile and ephemeral our existence can be in the grand scheme of things. So, as we continue to explore the universe and its mysteries, let us not forget that in the end, we are part of something much larger. Curiosity and the pursuit of knowledge are what drive us forward, through the darkness and toward the light. As we advance in this quest, let us remember that each small discovery can illuminate a dark corner of the universe, and perhaps one day we will discover not only the destiny of the cosmos, but also our place within it. How far will this exploration take us? The answer, like the universe, continues to expand, filled with possibilities and mysteries to unveil. How far does the universe extend? That is a question that has fascinated astronomers and philosophers for centuries. But did you know that beyond a certain point, there is a region of the universe that we will never be able to see? This phenomenon is known as the cosmic horizon, and it is one of the great mysteries of the universe's expansion. First, let's understand what the cosmic horizon is. Imagine that the universe began with a massive explosion, the Big Bang, and has been expanding ever since. As it expands, the light from distant galaxies also travels towards us. However, there is a limit. There is a point at which the light from some galaxies will never be able to reach us due to the speed of expansion. Can you imagine a universe where there are many things you will never be able to see? The speed of the universe's expansion is astonishingly fast. Some galaxies are moving away from us at such a high speed that light does not have enough time to reach us before they move too far away. This phenomenon creates a sort of barrier. The cosmic horizon is like a boundary in space, and beyond that boundary, the universe is a total mystery. But why does this happen? One of the reasons behind this accelerated expansion is the mysterious dark energy, which seems to be pushing the universe outward. However, dark energy does not only affect nearby galaxies, it also influences how the more distant ones behave. So even though the universe is expanding and galaxies are moving away, there is a limit to how much of that universe we can observe. Isn't it curious to think that there is a vast space filled with galaxies that we will never know? This leads us to another intriguing question. What lies beyond the cosmic horizon? In theory, there could be a universe as vast as the one we know, filled with galaxies, stars, and planets, but we simply cannot see them. If the universe's expansion continues, we could become trapped in a bubble of limited knowledge, never knowing what lies beyond. Have you ever imagined what it would be like to explore a universe that extends infinitely beyond what we can observe? The idea of a cosmic horizon also raises questions about the nature of time and space. If there is a limit to what we can see, does that mean there is a limit to what we can know? This makes us question our understanding of reality itself. Could we be living in a bubble of information, unaware that there is a vast cosmos beyond our sight? Moreover, the cosmic horizon is not fixed. As the universe expands, the horizon also changes. Galaxies that were once within our reach may eventually fall outside our horizon. This idea is unsettling because it suggests that over time we could lose contact with everything we know and love in the cosmos. What would happen if, in a distant future, humanity could no longer see the stars that guide us today? The expansion of the universe also affects how we perceive the past. The light from distant galaxies that we see today tells us stories about the universe as it was billions of years ago. However, the galaxies that are rapidly moving away from us are creating an effect in which their light may never reach us. How does this affect our understanding of the history of the universe? Could we be losing key pieces of the cosmic puzzle? It is fascinating to think that, although the cosmic horizon limits our vision, it also gives us a clue about how the universe is behaving at this moment. By studying the horizon, scientists can infer properties of the expansion and learn about dark energy. However, this also means that there are many unanswered questions. What mysteries lie in the regions we cannot see? The idea of the cosmic horizon is also intrinsically related to the concept of the universe's homogeneity. As the universe expands, it appears to be uniformly distributed on large scales. But how can this be possible if there are areas we will never be able to observe? This is another of the enigmas that cosmologists are trying to solve. In summary, the cosmic horizon not only limits our view of the universe, but also invites us to reflect on what it means to be human in such a vast cosmos. It reminds us that, although we have made great strides in our understanding of the universe, there is still a world of mysteries waiting to be discovered. Are we ready to accept that there is more than we can see? That is a question each of us must answer on our own journey of exploration and discovery. The expansion of the universe and its cosmic horizon are reminders that while we may be advancing in our quest for knowledge, there will always be more questions than answers. So when we look at the starry sky, we are not only observing what is in front of us, we must also remember that beyond the visible there is a vast universe full of secrets waiting to be revealed. What do you think? Would you dare to dream of what might lie beyond the cosmic horizon? What was the trigger that initiated the great expansion of the universe? This is a question that has intrigued scientists and dreamers alike since we began to explore the farthest reaches of the cosmos. Deep down, there exists an innate curiosity to understand the origin of everything around us. However, the answer to this enigma remains elusive. What could have caused that primordial explosion of energy and matter that gave rise to our current universe? Some experts suggest that it all began with an extraordinary event known as the Big Bang. But what triggered it? Was there anything before that moment? Most current models of cosmology fail to provide a clear and definitive answer. Many only describe what happened after the Big Bang, leaving the cause that initiated it shrouded in darkness. This lack of information leaves us with more questions than answers, and the mystery deepens. Imagine a moment when there was nothing, no time, no space, no matter. Then suddenly, bam, everything emerged from nothing. But is it really possible for something to arise from nothing? Current physics faces a dilemma. The laws that govern our universe seem not to apply to that primordial stage. How can we understand something that is beyond our frame of reference? Some scientists have proposed intriguing theories. One of them speaks of quantum fluctuations. In the vacuum, where apparently there is nothing, small variations can occur that might have triggered that first great explosion. But how can something so small have such an impact on the creation of an entire universe? It is a fascinating concept, but again, it leaves us with more questions than answers. And then there is the question of time. Before the Big Bang, did time exist? If time began with the universe, how can we talk about before the Big Bang? This is where the human mind can take unexpected turns. The notion of linear time as we know it may have been transformed in an instant, blurring the boundaries of what we understand. Amidst this confusion, another question arises. Could there have been other universes before ours? Some theorists suggest that the Big Bang might not have been a unique event, but part of an endless cycle of expansion and collapse. If this is true, it leads us to imagine a multiverse where each universe expands and contracts, giving rise to a series of Big Bangs. But how can we prove or disprove something that is beyond our observable universe? As we delve deeper into this mystery, the role of dark energy becomes increasingly intriguing. It has been suggested that this mysterious force may have been present even in the initial moments of expansion. Could it be that dark energy, which currently drives the acceleration of the universe, also played a crucial role in its creation? However, the nature of dark energy remains an unsolved puzzle, and we cannot forget the influence of gravity. Although many theories focus on expansion and its acceleration, gravity also plays a fundamental role. Why does gravity not seem to have slowed down the expansion from the beginning? The answer to this question could be key to understanding the very origin of the universe. Meanwhile, the search for the initial cause of the universe's expansion leads us to question our own existence. If we do not know where we come from, how can we understand where we are going? This dilemma confronts us with the fragility of our knowledge and the vastness of the unknown. The implications of all this are overwhelming. The existence of an initial event and the subsequent expansion push us to reflect on our own insignificance in the grand cosmic theatre. What are we, human beings? In comparison to the immensity of the universe, this thought can be both terrifying and liberating. Each new question about the cause of the expansion invites us to keep exploring, to keep inquiring. Science is a journey, not a destination, and each discovery brings us closer to unraveling the mysteries of the cosmos. Even if we never obtain definitive answers, the search itself is what gives meaning to our curiosity. And so, the mystery of the initial cause of the universe's expansion remains a testament to our unyielding desire to understand. Perhaps we will never come to know the complete truth, but each small step we take on this journey brings us closer to unveiling the unknown. The search continues, and with each question, we move a little closer to the secrets held by the vast universe. Dark energy is one of the greatest enigmas of modern cosmology. But what exactly is it? Imagine a vast ocean of mystery surrounding everything we know. This mysterious phenomenon seems to be behind the acceleration of the universe's expansion. Like an invisible force pushing everything around it. How can something we don't see have so much power? As scientists observe the universe, they discover that galaxies are moving away from us at increasing speeds. This acceleration has baffled astronomers, as it was traditionally thought that gravity should slow down the expansion. So why is this happening? This is where dark energy comes in, with its fascinating enigma. Although we cannot observe it directly, its effect is undeniable and has led to many theories about its nature. One of the most intriguing proposals is that dark energy could be a property of space itself. In this case, every time more space is created as the universe expands, more dark energy is also generated. But what does this mean for our understanding of the cosmos? This concept challenges our perception of gravity and matter, suggesting that the vacuum is not really empty but may be filled with energy. The idea that the universe is in a state of accelerated expansion also leads to other questions. Could dark energy be related to some form of unknown matter? Some scientists wonder if there is a new type of particle that we have not yet detected, one that could provide clues about the nature of this mysterious force. This opens up a range of possibilities, from the existence of hidden dimensions to new laws of physics that we do not yet understand. But it's not just about theories. Scientists have tried to measure dark energy through various observations, such as the study of supernovae and cosmic background radiation. However, the results are confusing and sometimes contradictory. Why can't we reach a consensus on its nature? It's like trying to touch a mirage. The more we try to get close, the more it slips through our fingers. Then the question of its impact on the future of the universe arises. If dark energy continues to dominate the expansion, it could lead to a very different future than we imagine. Some theories suggest it could cause a big rip, where the expansion becomes so intense that even atoms would be torn apart. Is this an inevitable fate for the universe? The idea of such an end can be terrifying. But it also invites us to think about the fragility of existence itself. Moreover, dark energy poses a philosophical dilemma. If the universe continues to expand indefinitely, what does this mean for life and matter as we know it? Are we doomed to watch everything drift away eternally, turning the cosmos into an increasingly empty and lonely place? These questions are not only scientific, they also touch on deep aspects of our nature as human beings. Some researchers propose that dark energy could be the legacy of an ancient state of the universe, a remnant from the time of the Big Bang. If this is true, then we might be looking into the past in a way we have never considered. Could the key to understanding dark energy be hidden in the early moments of the universe? With each discovery, we get a little closer to unraveling the mystery of dark energy. However, each answer seems to open the door to new questions. Is it possible that dark energy is linked to other cosmic phenomena such as dark matter or cosmic radiation? The interconnection of these elements could be the key to understanding not only the expansion of the universe but also its structure and ultimate fate. This cosmic puzzle reminds us of how little we truly know about the universe we inhabit. Dark energy challenges us to look beyond the obvious and to question what we think we understand. As we continue to investigate, we are likely to face a reality much more complex than we imagine. Theories about dark energy could radically change our understanding of the universe. The search for answers is underway, and each new discovery could be a step towards solving one of the greatest mysteries of cosmology. But even as we progress, it is possible that we may never fully comprehend this force that seems to be at the heart of the universe's expansion. As we reflect on dark energy, it becomes evident that we are in the midst of an intellectual adventure that goes beyond what we can see. The exploration of this phenomenon invites us to keep asking, to keep searching, and above all to marvel at the vastness of the universe and the intricate web of mysteries that still surround us. The story of dark energy is, in essence, the story of our ongoing effort to understand the cosmos in all its complexity. The homogeneity of the universe is a fascinating enigma that has puzzled scientists for decades. Why does the cosmos appear so surprisingly uniform on large scales? When we look up at the sky, we find that, despite the vast differences in matter density between galaxies, the universe extends in a homogeneous manner. This uniformity is perplexing, especially considering that the universe has been expanding since the Big Bang. How is it possible that after all this time, the most distant regions of the universe behave so similarly? This mystery becomes even more intriguing when we take into account that some areas of the cosmos are moving away from others at incredible speeds, often exceeding the speed of light. Despite these distances and velocities, the fundamental properties of the universe seem to maintain a surprising coherence. What lies behind this cosmic harmony? One of the most persistent questions is, why doesn't the universe present a more chaotic mix of structures and densities? If we consider that gravity should have attracted matter towards areas of higher density, then why don't we see a cosmos filled with dense zones and absolute voids? The answer seems to be related to the expansion of the universe itself. As space expands, so do regions of matter, fostering a balance that allows for this homogeneity. But could it be that the expansion of the universe is smoothing out irregularities over billions of years? This phenomenon could be one of the keys to understanding why the universe looks so similar no matter where we look. However, this raises new questions. Is there a limit to how homogeneous the universe can be? The theory of inflation, which suggests that the universe underwent rapid growth in its early moments, may offer a clue. During this brief period, the universe would have expanded exponentially, smoothing out any irregularities that may have existed. But although this theory has substantial support, a great mystery remains. Is it possible that there are more factors at play than just inflation? Some scientists are exploring the idea that homogeneity could be an effect of dark energy, that mysterious force that seems to be accelerating the expansion of the universe. Could dark energy be influencing the distribution of matter and therefore the homogeneous appearance of the cosmos? However, the nature of dark energy remains one of the greatest puzzles of modern cosmology. The question of the relationship between homogeneity and isotropy also arises. While homogeneity refers to how matter is evenly distributed on large scales, isotropy implies that regardless of the direction we look, the universe will appear the same. Why does the cosmos seem so uniform everywhere? This question intertwines with homogeneity, leading scientists to wonder if there is a deeper background that explains this symmetry. As telescopes advance and allow us to look further back in time and space, patterns and variations in the cosmic microwave background have been discovered. These small fluctuations, which are remnants of the Big Bang, reveal that the universe is not completely homogeneous. However, these variations are so subtle that they raise new questions. Why are they so tiny? What does this mean for our understanding of the structure of the universe? The key to understanding the homogeneity of the universe may lie in the understanding of gravity itself. When we look around, we see that gravity tends to attract matter towards it. But what happens when the force of expansion is stronger than gravity? This balance between expansion and gravity could be the reason why irregularities have remained in a relatively uniform state over time. As we delve into the question of homogeneity, we must also consider the scale at which we are observing. Could it be that if we looked at smaller scales, we would see a much more chaotic universe filled with irregularities? Perhaps the universe is like a vast ocean where the largest waves are visible from afar. But at closer levels, the surface is a whirlwind of activity. Ultimately, the homogeneity of the universe invites us to reflect on our own existence within it. If the cosmos is fundamentally uniform, what does that mean for us as human beings? Are we truly alone in the vastness of space, or are there other forms of life in other corners of a universe that, despite its homogeneity, could be surprisingly diverse? The quest for answers to these mysteries about the homogeneity of the universe continues, driving scientists to devise new theories and experiments. In our pursuit of understanding the cosmos, each discovery opens the door to new questions. Homogeneity is just one of the many pieces of the cosmic puzzle, and each of these pieces brings us closer to unraveling the secrets of the universe. What if I told you that the universe might be destined for a cold and empty death? In the fascinating world of cosmology, there exists a scenario known as the Big Freeze, which imagines a future where the expansion of the universe continues indefinitely. But how did we arrive at this unsettling conclusion? To understand it, we first need to explore how the universe behaves today. The expansion of the universe is an astonishing phenomenon since the Big Bang. Approximately 13.8 billion years ago, the cosmos has been continuously growing. Galaxies are moving away from each other, and what is even more surprising is that this expansion is accelerating. But what is the ultimate fate of this growth? Some scientists suggest that if the expansion continues, the universe will eventually cool to the point where matter will disperse and stars will extinguish one by one. Imagine a universe where stars, those bright spheres of gas in the sky, become distant memories. Over time, galaxies will separate so much that interactions between them will be practically impossible. What will happen to life? The light from the stars will fade and space will fill with darkness. But why is it believed that this could happen? The key lies in dark energy, that mysterious force that seems to be behind the acceleration of the universe's expansion. Although we do not fully understand its nature, dark energy is thought to act as a kind of cosmic repellent, causing galaxies to move apart at an ever-increasing rate. If this trend continues, the Big Freeze becomes a very real possibility. But let's talk a bit more about the temperatures in this bleak future. As the universe expands, it cools. The atoms that make up everything we know will scatter into a vast void. In this scenario, temperatures will drop drastically, and matter will become something almost unrecognizable. How can we imagine a universe without heat, light, or life? The Big Freeze theory also raises questions about time. In a constantly expanding and cooling universe, what does time mean? Will it continue to flow, or will it become irrelevant in a dead cosmos? Some theories suggest that eventually, time itself could reach a point where it no longer makes sense. Is it possible that one day, what we understand as time will come to a complete stop in a cold, dark universe? Now let's consider the possibility that gravity, the force that holds galaxies together, also plays a crucial role in this scenario. If gravity cannot counteract the repulsion of dark energy, then the expansion will continue. However, if at some point gravity manages to overcome dark energy, we could face a very different fate. But is that likely? The answer remains uncertain. Another intriguing aspect of the Big Freeze is how it will impact what remains of life. While there are currently billions of stars in the universe, the vast majority of them will eventually extinguish. Smaller stars like red dwarfs may survive a bit longer, but they too will meet their end. What legacy will these dead stars leave behind? perhaps just an echo of what was once a vibrant universe, black holes. Those cosmic mysteries that devour the matter around them will also face a fate in the Big Freeze. It is estimated that over time, even they could evaporate through a process known as Hawking radiation. What if the last remnants of matter and energy in the universe were reduced to nothing more than an absolute void? As the expansion continues, the idea of the Big Freeze leads us to reflect on our own existence. What does it mean to be part of a universe that is destined to cool and die? The search for answers to these questions drives us to explore not only the cosmos, but also our place within it. Science still has much to discover about the universe and its expansion. Although the Big Freeze is just one of many theories, it serves as a reminder of how fleeting existence can be. Every star we see in the sky is a testament to a past that will eventually fade into darkness. Human curiosity drives us to keep investigating, to keep asking. Perhaps along the way we will discover ways to better understand not only the universe but also our own nature. In this sense, science and exploration become a way to challenge the fate that seems to await us. In conclusion, the Big Freeze is a fascinating and terrifying scenario that invites us to think about the future of the universe. The ongoing expansion driven by the enigmatic dark energy could lead us to an end dominated by cold and solitude. However, as long as we continue exploring, learning and sharing, we also keep alive the spark of curiosity and the desire to understand the vast universe in which we are immersed. The expansion of the universe is a fascinating phenomenon that poses an intriguing dilemma. If the entire universe is expanding, why aren't the atoms and planets that make up everything we know also expanding? What happens at those smaller scales that seem to resist this cosmic expansion? To understand this, we must delve into the forces acting in our environment. When we talk about the expansion of the universe, we refer to the way galaxies move away from each other in an ever-growing space. But what about the smaller objects that are part of our daily lives? Why do atoms, which are the basic units of matter, remain intact despite the universe expanding? The answer seems to lie in the nature of the forces that govern our reality. Gravity is one of those forces. On a cosmic level, gravity is the mechanism that binds galaxies together and forms massive structures. However, at smaller scales, such as those of planets and atoms, gravity acts differently. Its influence becomes more relevant in how objects cluster and stay together. Could it be that gravity is so powerful that it counteracts the expansion of the universe at these levels? Another fundamental force that plays a crucial role in this enigma is the electromagnetic force. This force is what holds electrons and protons together within atoms. The energy required to break those bonds is considerably greater than the energy associated with the expansion of space. This suggests that even though the space between galaxies is stretching, the forces that keep atoms together are strong enough to resist that expansion. But another question arises: what happens with the interactions between different scales? As the universe expands, one might think there would be some effect on smaller structures. However, the reality is that the laws of physics governing the behavior of atoms and molecules are independent of cosmic expansion. This implies that although large-scale space is stretching, the rules that govern matter at tiny scales remain constant. Delving into this mystery, we find that cosmic expansion is a phenomenon that operates on a large scale and manifests through the distance between galaxies. But is it possible that there is a point at which this expansion does affect smaller structures? Could there be a moment when the force of expansion surpasses gravity and other forces at play? This is an underexplored area, but it is fascinating to think that in the future, if the expansion of the universe continues to accelerate, we might face a scenario where even atoms are affected. As we reflect on this, an intriguing idea emerges. If the universe is expanding and this does not affect atoms, what does that mean for the nature of our universe? Is it possible that there are other types of interactions that we have yet to discover? Perhaps the answer to this mystery lies beyond our current understanding and requires a new way of thinking about the fundamental forces that govern the cosmos. Some scientists have proposed theories about how expansion could have effects on smaller scales, suggesting that as the universe expands, space itself might be influencing the properties of matter. However, these ideas are still in the realm of speculation and require further research to be validated. Are we on the brink of a new paradigm in our understanding of the universe? The challenge is that, while the expansion of the universe is an observable and measurable phenomenon, its impact on the matter around us is much more subtle. The laws of physics we know have been formulated based on local observations, but what happens when we apply those laws to cosmic scales? The answer to that question could provide us with a completely new insight into how the universe works. As we continue to explore this enigma, it is important to remember that science is constantly evolving. New technologies and discoveries could change our perception of expansion and its relationship with matter. Perhaps in the not-so-distant future, we will unravel this mystery and understand how cosmic forces interact with the world around us. The idea that the universe expands while atoms remain unchanged leads us to question our understanding of reality. What other mysteries does the cosmos hold for us? As we explore and discover, each answer leads us to new questions, and this endless cycle is what drives human curiosity. The expansion of the universe is just one piece of the puzzle. On our path toward a complete understanding of the cosmos, each small mystery we unravel brings us closer to the truth about our existence. As we continue to investigate, let us remember that every unanswered question is an invitation to explore beyond the known. The expansion of the universe is a fascinating phenomenon that leads us to question its future. One of the most unsettling scenarios proposed by scientists is the Big Rip, a hypothesis suggesting that the expansion of the universe could be so intense that eventually it would tear apart everything we know, from galaxies to the smallest atoms. But how is it possible for the expansion to reach such an extreme point? To understand the Big Rip, we must first remember that everything in the universe is in constant motion. Galaxies are moving away from each other, and this rate of expansion is not only fast but is also accelerating. But what would happen if this acceleration continued indefinitely? The answer could be devastating. Over time, the force behind this expansion, known as dark energy, could overpower everything. And what would happen then? Imagine a universe where dark energy becomes the dominant force, even challenging gravity. In this scenario, galaxies, which today seem so firm and united, would begin to lose their cohesion. The attractive forces that hold stars together would be overwhelmed by the acceleration of the expansion. Can you imagine a cosmos where galaxies dissolve into the vacuum of space? As this expansion intensifies, a chain reaction would occur. Stars would separate from their galaxies, and eventually solar systems like ours would also be affected. How would you feel knowing that in a distant future the Sun and all the planets orbiting it could be cast away from their cosmic home? The idea is terrifying, but science compels us to contemplate these scenarios. But the Big Rip doesn't stop there. As the expansion continues, even atoms could be threatened. The force that holds subatomic particles like electrons and protons together could be overwhelmed by the acceleration of space. Imagine the most fundamental things that make up matter crumbling. What would happen to life as we know it? For physicists, this extreme scenario raises complicated questions. What kind of conditions would we need to observe in the universe for the Big Rip to become a reality? The answer remains uncertain. Some models suggest that certain parameters of dark energy could be responsible for this acceleration. But why have we not yet found a clear answer to this enigma? The idea of a Big Rip also leads us to question time itself. If the universe expands in this way, does it mean that time could also be affected? Could there be a point where time stops along with the disintegration of the fabric of the universe? These questions may seem like they are straight out of a science fiction movie, but for cosmologists, they are real subjects of study. Moreover, this theory raises the need to revise our understanding of the cosmos. If the Big Rip is a real possibility, we should ask ourselves if there are other similar scenarios that could occur. Could there be an unknown force driving the expansion in such a way that the boundaries of the universe are constantly reconfigured? Studies on the Big Rip also lead us to investigate the nature of dark energy. What exactly is it? So far, scientists have managed to describe it as a force that acts in ways that challenge our traditional understanding of physics. Could it be that this dark energy is more than just a simple expansive force? Perhaps it has properties that we have yet to begin to explore. As astronomers and physicists continue to observe the universe, each new discovery could bring us closer to answering these questions. Observations of supernovae and large-scale structures provide us with clues about the nature of the expansion. But will it be enough to unravel the secrets of the Big Rip? In the end, the idea of the Big Rip reminds us that the universe is a place of constant change and evolution. The expansion, while fascinating, could lead us to unexpected destinations. Are we prepared to accept that the cosmos could end in such a drastic and surprising way? Reflecting on these possibilities invites us to contemplate not only our place in the universe, but also the ultimate fate of everything we know. So, as we continue to explore the vast cosmos, the question persists: will the Big Rip be our future, or simply another mystery that the universe still holds in its immensity? It serves as a reminder that, as we look to the sky, we must also be willing to confront the unknown in our quest for answers. The idea of eternal inflation may seem like something out of a science fiction novel, but in the world of cosmology, it is gaining quite a bit of relevance. What does this concept really mean? Imagine a universe that not only expands but does so infinitely, creating bubbles of space-time that separate from one another, forming parallel universes in the process. Isn't it fascinating to think that we could be just one bubble in an endless sea of universes? But how did we arrive at this idea? The theory of inflation, which emerged in the 1980s, suggests that in the initial moments after the Big Bang, the universe underwent an extremely rapid expansion. This expansion was so accelerated that it allowed the universe to stretch to unimaginable sizes in an incredibly short period of time. However, eternal inflation takes this idea a step further, suggesting that this process was not an isolated event but could be occurring continuously in different places in the cosmos. Now, how do we know this is possible? The mathematical models that scientists have developed allow for this possibility, supported by observations of cosmic radiation and the distribution of galaxies. But here arises another intriguing question. What is inside those bubbles? Each of them could have different laws of physics, different constants, and even different forms of life. Can you imagine a universe where gravity is weaker, or conversely, one where electromagnetic forces are so strong that life as we know it would be impossible? As we explore this idea, more questions arise. If infinite universes truly exist, how can we know anything about them? The answer is that, in most cases, we cannot. These bubble universes would be completely separate from our own, and what happens in one would not affect the other. But what if we could someday find a way to communicate or travel between them? Science fiction has explored this topic thoroughly, but in the realm of real science it remains a mystery. The notion of eternal inflation also raises questions about the fate of our own universe. If it is in constant expansion, does that mean that life and matter as we know them will continue to exist forever? Or conversely, are we doomed to a cold, empty end where the expansion continues to push galaxies farther apart until nothing remains? In this context, it is interesting to consider the role of dark energy. This mysterious force is driving the acceleration of the universe's expansion. Could it be that this same dark energy is responsible for the creation of new bubbles in the process of eternal inflation? The connection between these concepts is still unclear, and scientists are working hard to solve this puzzle. Furthermore, if eternal inflation is true, it means that the history of the universe is much richer and more complex than we imagine. Instead of being a singular event, the creation of the universe would be a continuous process, full of cycles of expansion and contraction, of birth and death. Is it possible that there are universes that had a beginning similar to ours but are now in a completely different phase of their evolution? And we cannot forget the philosophical impact of this idea. If there are countless universes, each with its own realities, what does that mean for us? What are the implications of our existence in an infinite sea of possibilities? It may seem that our lives are insignificant in the grand scheme of the multiverse, but we could also be part of something much larger and more meaningful. Finally, let us reflect on the implications of eternal inflation in our quest for answers. In a universe where each bubble is a world in itself, perhaps our questions about the origin and fate of the cosmos are just the beginning. The exploration of these mysteries could lead us to discoveries that would change our understanding of existence. Are we ready to face what we uncover on our journey through the multiverse? Eternal inflation is not just a theory, it is a window into the possibility that our understanding of the universe is much more limited than we think. As we look up at the sky and contemplate the stars, perhaps we should ask ourselves not only what is out there, but also how many universes surround us, waiting to be discovered. Have you ever felt small when looking at the stars? That vastness we see in the sky is just a fraction of what truly exists. The expansion of the universe offers us an exciting view, but it also poses an intriguing puzzle. What lies beyond what we can observe? As the universe expands, it seems that more and more galaxies are moving away from us. But what does this mean for our understanding of the cosmos? Astronomers have determined that the observable universe has a limit. But why can we only see a part of the universe? The answer lies in the speed of light. The light from the most distant stars and galaxies takes so long to reach us that we can only see what has had time to arrive. So what is beyond that boundary? It is an area full of mystery and speculation. Imagine a balloon being inflated. As the balloon expands, the points drawn on its surface move away from each other. Now, if the balloon is the universe, what we see are the points that are closest to us. But as the universe continues to expand, those more distant points move away at speeds that exceed even the speed of light. This means there are parts of the universe that we will never be able to observe because the light from those regions will never reach us. Isn't it fascinating to think that there is a vast ocean of galaxies, stars and planets that remain beyond our reach? This phenomenon leads us to ask, how does this affect our understanding of the universe? If we can only see a small part, could it be that our theories and models about the expansion of the universe are incomplete? The idea that there is more beyond what we can perceive challenges us to rethink our notions of what the universe is. Moreover, some suggest that the observable universe is just a bubble in a sea of universes, each with its own rules and expansions. Could it be that alternative universes exist that we will never come to know? Every time we look up at the sky, are we only seeing a small reflection of what is really there? The expansion of the universe also raises the question of whether there is something beyond our cosmic horizon. Is it possible that there are galaxies that we will never be able to see, even with the most powerful telescopes? The answer seems to be a resounding yes. This means that our understanding of the cosmos is like a puzzle with many missing pieces. But why is it so important to understand what lies beyond our observable universe? The answer lies in the quest for the whole, the understanding of how the universe works in its entirety. If we manage to unravel the mysteries of what lies beyond, we could come to better understand the nature of matter, energy, and perhaps even time itself. So what happens to the rest of the universe? The expansion suggests that there could be parts of it that are so far away that we will never have information about them. This raises questions about the future of our own existence in this vast cosmos. Are we doomed to only know a fraction of reality? Scientists warn us that as the universe expands, galaxies are moving further away. Some may be so distant that they will never be part of our observable universe. So, what does this tell us about our place in the cosmos? Are we truly alone in a vast emptiness, or is there more life and matter that we simply cannot see? In this context, the expansion of the universe becomes a reminder of our own limitations as human beings. As we strive to understand the cosmos, we must accept that there are limits to what we can know. But does that mean we should stop searching? Of course not. Every discovery we make about what lies beyond brings us closer to a more complete understanding. Science is constantly evolving, and although we can currently only observe a part of the universe, we must never stop exploring. Those unanswered questions are what fuel human curiosity. Perhaps one day we will manage to build technology that allows us to glimpse beyond our cosmic horizon. In conclusion, the expansion of the universe is not just a physical phenomenon. It is an invitation to reflect on the limitations of our perception. It reminds us that what we know is just a fragment of a much larger and more mysterious whole. So the next time you look at the starry sky, think about what lies beyond what you see and the infinite possibilities that may be waiting to be discovered. The cosmos is full of surprises and mysteries waiting to be unveiled. The expansion of the universe is a fascinating phenomenon, but what role does gravity play in this process? Could the very force that holds galaxies together be influencing how the cosmos expands? Gravity? That seemingly simple force adds an impressive level of complexity to our understanding of the universe. Let's begin with an intriguing question. Can gravity really slow down the expansion of the universe? If we think about what happens in our own cosmic neighborhood, we see that galaxies are in constant motion. However, gravity acts like a magnet, pulling galaxies toward each other. This leads us to wonder if gravity could be responsible for the slowing down of the universe's expansion. But what happens when we consider that the expansion of the universe is accelerating? This is a true puzzle that scientists are still trying to solve. The key might lie in dark matter, but what exactly is dark matter and how does it relate to gravity? Although we cannot see or directly detect it, astronomers have concluded that it must exist due to its gravitational effects on visible matter. However, its influence on the expansion of the universe is a topic of debate. Does dark matter help slow down the expansion, or is it simply being dragged along by it? The answer to this question could change everything we know about the structure of the universe. As we delve into the enigma of expansion, we find another fascinating aspect: the interactions between galaxies. When two galaxies come close, gravity can cause them to merge. But what about galaxies that are billions of light years away? The expansion of the universe means that even though gravity acts on a galaxy, the distance between them continues to increase. Could it be that gravity, while powerful, is not enough to counteract the acceleration caused by other factors? And speaking of factors, we cannot forget dark energy. This mysterious component of the universe seems to be the main driver of the acceleration of expansion. But how does dark energy relate to gravity? Some scientists believe that dark energy acts like an anti-gravity, pushing galaxies to separate further and further apart. Is it possible that gravity, instead of being a unifying force, becomes a secondary force in a universe dominated by dark energy? Moreover, gravity plays a crucial role in the formation of structures in the universe. Galaxies, clusters, and superclusters form due to gravitational attraction. However, as these structures form and evolve, the expansion of the universe continues. Could the gravitational forces that hold these structures together indicate how gravity confronts expansion? In this context, every time we look at the night sky, we marvel at the vastness of the universe. But what if gravity were acting differently in different parts of the cosmos? This variability could have a profound effect on how the universe expands overall. Could it be that gravity is not uniform but varies according to the region of space? This would open a new field of study in cosmology. Observations of the distribution of galaxies also lead us to ask, can gravity influence how we perceive the expansion of the universe? If gravity affects how galaxies cluster, perhaps it is also affecting our understanding of expansion. Are we seeing a distorted image of the universe due to gravity's influence on our own perception? Every time a new discovery is made in the field of cosmology, we are presented with more questions than answers. For example, how does the gravity of a massive body, like a supermassive black hole at the center of a galaxy, affect the expansion around it? In this case, gravity could be creating a local effect that challenges the idea that the expansion of the universe is a uniform phenomenon. As we explore further, another enigma arises. could gravity itself be changing over time? If gravity is not a universal constant but evolves, this could have profound implications for the expansion of the universe. Are we facing a universe where the fundamental forces, including gravity, are subject to changes over millions of years? And finally, returning to the idea of accelerated expansion, could it be that gravity is a factor in this acceleration but only under certain conditions? Perhaps there are regions of the universe where gravity acts differently, allowing expansion to accelerate more rapidly. This possibility leads us to question our current theories and explore new frontiers in cosmology. So, at the end of the day, the relationship between gravity and the expansion of the universe is a mystery that we have not yet fully deciphered. Each discovery brings us closer to the truth, but it also leaves us with more questions. The search for answers about how gravity influences the expansion of the universe continues, and with it, our desire to understand the cosmos we inhabit. What other surprises does the universe hold in this endless quest for knowledge? What do we really know about the expansion of the universe? Throughout this journey, we have explored a series of enigmas that have left us with more questions than answers. But what does all this mean for us? The expansion of the universe is not just an astronomical phenomenon, it is an open door to understanding our own existence. What is the purpose of investigating these mysteries? The answer is simple. By unraveling the secrets of the cosmos, we are also getting to know ourselves. The acceleration of the expansion, for example, poses a fascinating dilemma. Why, despite the gravity that should be slowing down the movement, does the universe seem to be accelerating? The search for dark energy responsible for this behavior leads us to question the very nature of reality. Could it be that dark energy is a completely new and unknown phenomenon to us? This type of question pushes us to the limits of our understanding. What about dark matter? Although we cannot see it, we know it is there, shaping the structure of the universe. But is it possible that dark matter not only participates in the expansion but also influences it? As we delve deeper into these concepts, we encounter the intriguing idea that all this time we have been misinterpreting the role of dark matter in our cosmic history. The geometry of the universe is another mystery that prompts reflection. Is it really flat, curved, or infinite? Each of these possibilities has profound implications for how we understand expansion. Could it be that the universe has no edge or center, and that the expansion is simply an illusion created by our limited perception? These questions are not only an intellectual challenge, but also invite us to reconsider how we position ourselves in this vast cosmos. The notion of bubble universes adds another layer of complexity. If our expansion is just one among many, what does that mean for our conception of reality? The possibility of a multiverse could radically change our perspective on existence. Does this mean that each of us could be part of infinite realities, each with its own story and evolution? This kind of speculation may seem like science fiction, but it is also an invitation to explore the unknown. The enigma of cosmic radiation and its variations raises another level of inquiry. These small anomalies do not quite fit with our current models. Why is this happening? Are we missing something crucial in our understanding of expansion? As we delve into these mysteries, we realize that science is a constantly evolving journey, where each answer generates new questions. The Hubble tension is a reminder that even in science, sometimes things are not what they seem. Two different methods of measuring expansion offer us contradictory results. How is it possible that two such distinct approaches reach such disparate conclusions? This dilemma not only challenges us, but also invites us to reconsider how we interpret data and how our knowledge is constructed. The relationship between expansion and time is equally fascinating. Could it be that the flow of time is intrinsically linked to the expansion of the universe? By exploring this connection, we face the possibility that time is not a constant, but is influenced by the very cosmos that surrounds us. What implications would this have for our understanding of life and change? As for the ultimate fate of the universe, theories about its expansion present unsettling scenarios. Will it continue to expand forever, leading to a big freeze where everything cools down and becomes desolate? Or could it eventually collapse in a big crunch? The uncertainty about the future of the cosmos confronts us with existential questions about our own existence and the legacy we will leave behind. The frontier of the cosmic horizon reminds us that there are limits to what we can observe and understand. Beyond a certain point, the expansion moves everything away so quickly that we will never see it. What lies in that vast unknown? Could it hold secrets that forever change our view of the universe? The initial cause of the expansion remains a mystery. What triggered the Big Bang that set everything we know in motion? This enigma invites us to look beyond our own temporal and spatial limits, suggesting that the origin of the universe could be even more astonishing than we imagine. Dark energy, with its influence on cosmic acceleration, remains an unsolved puzzle. What is it exactly, and how does it affect our expanding universe? This mystery forces us to confront our own ignorance and accept that there are aspects of reality that we may never fully understand. Finally, the mystery of homogeneity leads us to question the uniformity of the universe. Why does it seem so balanced and orderly, despite the chaotic forces at work within it? The expansion of the universe could be the key to unraveling this enigma, reminding us that in apparent simplicity, there may be surprising complexity. In summary, the expansion of the universe is a topic that accompanies us in our quest for truth. Each mystery we explore not only brings us closer to understanding the cosmos, but also invites us to question our own existence. It reminds us that, just like the universe, our knowledge is in constant expansion. What other secrets does the cosmos hold for us in the future? The exploration has only just begun, and what we discover could change the way we see our place in the vast universe.